Okay, so this is the second half part of the section 5.1. Well, on the previous one, that I accidentally stopped recording the video, so I just have to create the second part of section 5.1. So starting from problem number 35, it's a composition of two functions, but one of them is a radical expression. So you have to be careful about the domain of the function. So first one, f of x is a squared polynomial, and gx is square root of x minus 2. So input is restricted by this inequality. Now, first one is f of gx, which is square root of x minus 2. And you're going to plug in into the fx. So it's going to be input square plus 3, which is equal to x minus 2 plus 3, which is x plus 1. So the domain is basically, domain for f is anything. So as long as g is defined, that's okay. So anything above or equal to 2 works. So the answer is x plus 1. And the domain is any number above or equal to 2 works. Okay, now harder one. Let's change the order of g and f. So it's going to be g of fx. And that is equal to square root of input minus 2, which is square root of x squared plus 1. Now, fx is defined for all real numbers. So this part is okay for any number. But g has a limitation. So here's the restriction. So domain is input for gx must be greater than or equal to 2, which means x squared is greater than or equal to -1, which is always true, right? X squared is always greater than or equal to 0. So this is always true. So in this case, the domain is any number, all real numbers. So it's going to be square root of x squared plus 1. And the domain is actually all real numbers, so it's going to be this. Okay, well, FF is quite easy because it's just a polynomials. So it's going to be f of x, which is f of x squared plus 3, which means input square plus 3, which is x the fourth plus 6x squared plus 9 plus 3. Okay. What? Oh, I typed wrong. Yeah. Okay, and the domain for combination of two polynomials is all real numbers. Okay, hard one, D. So what is g of x, which is equal to g of square root of x minus 2, and we know that x must be greater than or equal to 2. Now, you want to plug in this one into gx, so it's going to be square root of x minus 2 minus 2. And the domain for g is input must be 2 or greater. So this must be greater than or equal to 2, which means x minus 2 must be greater than or equal to 4. So x must be greater than or equal to 6. Looking at the restriction, one said at least 2, another said at least 6. And both of them must be true. So you are going to take an intersection of those two restrictions. So x must be equal to 6 or higher. Okay, the expression is a square root inside a square root, so it's ugly. I need to parentheses square root of x minus 2 minus 2. Okay, and the domain is x is greater than or equal to 6. Okay. Now number 37. So again, it's a composition of two functions. two fractions. So f of g of x, first of all. So that part A is f of g of x, which is f of x plus 1 over x minus 6. Now, clearly, the domain is everything except 6. Now, you plug in into x, f of x. So it's going to be input minus 5 over input over, plus 8. And the restriction is denominator is not equal to 0. So this cannot be equal to 0. So this is another restriction. Let's multiply top and bottom of this complicated expression by x minus 6. Multiply this one by x minus 6 and multiply this one by x minus 6. That's going to give us x plus 1 minus 5 times x minus 6. Denominator becomes x plus 1 plus 8 times x minus 6. Simplifies the numerator into ax plus b form. It's going to be negative 4x plus 31. Denominator will become 9x minus 47. So basically, x cannot be equal to 47 over 9 from this expression, which is same thing as this. And also, x cannot be equal to 6. So the answer is minus 4x plus 31 over 9x minus 47. And the domain is anything except 6 and 47 over 9. I typed wrong. Oops. Oh, I have point dot here. Okay, should be working. Okay. So likewise, we're gonna do the same thing for B, C, D. So part B will be something like this. Okay, and I'm gonna do similarly for C and D, but I'm gonna skip the explanation for now. Let's move on to the next program. Okay, number 41. Now fx is x to the power of 13. G of x is 13th root of x. I'm sorry, excuse me. Yep. So f of g of x is equal to f of g of x, which is 13th root of x. That is 13th root of x to the power of 13. Well, remember that x to the power, nth power of x to the power of n is equal to x if n is odd. When n is even, you have to be careful about the sign. When n is even, that's going to become, well, even if it is n is even, it's, as long as x is positive, it's this. Yeah. If x is greater than 0 and n is even. So in this case, this is equal to x. So it's going to become x. And the domain, likewise, if we do g of f of x, it's going to be g of x to the power of 13, which is 13th root of x 13th. Now again, if n is odd, x to the n to the power of nth root is equal to x if n is odd. When n is even, you have to be careful because this becomes absolute value of x. Well, since 13 is odd, this is equal to x for what? For any value of x. So these two results kind of telling us that f of x, x to the power of 13 and g of x, 13th root of x are inverse to each other, which is the topic in the next section. Okay, Now, we are just going to do the same thing. So it's going to become, it's kind of inverse to each other. So it's going to be x. This is also equal to x. And they are identical because the domain is the same and input and output is also identical. Okay, number 49, which is about, oops. So number 49 is decomposing a given expression into two simpler functions. So consider this function as doing something like this. So we start with x. You want to get x squared by squaring the input. Then you want to add 9. And then you want to take a square root. So there are 3 different operations given to the input to get the result. The decomposing into a pair of 2 functions means, so first function might do only first one, then the second function does the rest. If this is the case, f of x is going to give you a square of the input value, while the g of x is equal to adding 9 and taking a square root. Oops, I made a mistake. Because the program is saying f of g, so first function should be g. So I should change like this way. So first function does the squaring, and second function does the adding and the square root. So looking at these choices, there is no choice corresponding to this. So let's forget about this. Splitting into two functions could be considered as like these two and this separately. So in this case, g of x gonna do input square plus 9, while f of x only do taking a square root of the input. And looking at the choices, I can see the choice B is this, so it's gonna be working. Okay. I think that complete the homework assignment for section 5.1 this for sure. Yep. So thank you for listening. See you next time.